Welcome to Inside Builder channel. How LLMs execute code and commands on your computer, part 9, video 3. We'll be diving into the subprocess usage to execute commands on your local computer using the LLMs. So command execution. So let's dive into that. In the last video, we saw code execution. In this, we are going to look at subprocess agent. The process of the command execution is very similar to code execution. Only difference is instead of the code getting generated, the command itself gets generated. So the commands and the code, the difference, etc. I discussed in the first video 1 of this part 9. Let's go to the code execution directly and let us execute the code. So what I'm going to do is I'm going to close couple of that's done. So I'm going to execute the code. So Python subprocess. So this subprocess underscore crew.py is already present in the same folder called interpret underscore code, and I'll be showing you the output in a minute. And in the meantime, I will try to open the folder, open the file. So subprocess crew, and this subprocess crew is using the ShellExecutor tool. I'll be showing how the ShellExecutor tool is, and you'll be seeing it's a pretty simple execution process. And here I'm telling it execute the Python script basic exec.py. So this is the key. So let us go back and you'll see that it has actually executed the basic exec.py. You can see that here. And if you scroll up, you'll see the tool input is the command basic exec.py, and this is how it has executed it. So if you want, I can actually give a different request here. So instead of this, I can say list the files in the current directory. So this is a pretty simple example, right? List the files in the current directory, and let me execute this again. Now this time this is going to list what are the various files that is present in the current directory. The point I wanted you to take away from this in this entire discussion is that LLMs have to get the output, right? It has to take the output of this code. So you see the ls-l is the command, and that is getting executed, and you see this output. So this output has to go back to the LLM and it can be processed further. This is the point I wanted you guys to keep it in your mind, and that's how the agents work. You have to realize that this process where the command generation, the command execution, and the final output, so this loop goes to the next agent also. You can actually take it to the next agent. You can chain the agents, you can make a flow out of it, you can create complex executions using this understanding. So learning about tools is important, and learning about these two tools, especially the code execution and subprocess tool, is critical, right? So let's go back and let us look at the ShellExecutor tool. So the ShellExecutor tool is similar to the other tool that we discussed. It's starts with the base model ShellExecutor schema, which is a Pydantic base model, and it is asking for a command. So this is more simpler. So this is asking just for a command. It's not asking for any kind of installation. Believe me, you can make the ShellExecutor little more comprehensive, and you can ask for a lot of information that you need for executing a particular command. And the LLMs, if they are properly trained, then they can give you all these things. It can give you the working directory, it can give you the environmental variables, it can make you to set the timeout, whatnot. Even it can give you a list of installation targets, like the various apt-get install programs that you need to get installed before you execute the command. All of these things are possible. So base model Pydantic schema is one of the ways where you force the LLMs to give you the output that you want. This is useful in many places, not just in tools. It is also useful in the output that you expected output in the tasks also. So if you go back to other videos, there I discussed this point, where the Pydantic output, whether it is expected as output as Pydantic or output as JSON, you have to still give the schema there. So take a look at that, you will understand what I'm trying to say. Next is the class. So the tool by default is a function, but the class that you are wrapping here, so we are wrapping the function, the tool function, into a shell executor tool, so that it is easier for you to get the arg schema. The arg schema is the command that we want from the LLM, right? So it is easier to tell the LLM that, okay, you need to follow these kinds of set of rules when you are generating the command. So it's kind of all these things are, kind of supporting the prompt that gets pushed into the LLM. So keep these things in mind. The docstring that you see here from line number 34 to 40, the field description that you see here in line number 14, all these things support in making the prompt that goes to the LLM much more rich and has additional instruction on what exactly needs to be done. Instead of you giving all these things one by one every time when you are going to call a tool, this is already inbuilt into that. So you need to understand these things inside out. That's how LLMs work. That's how the agents are working. So fine, let's move forward. Here the run command is pretty simple. So run command is just taking the command. So rest of the things are, as of now commented it out. You can actually test this same code and you can see what kinds of challenges you are facing. Once the run command takes the command, it goes into the function, and here you see that I am using the process equal to subprocess.popen, which is very similar to what we did here in line number 18 to 24. Under basic underscore subprocess.py, so I explained how this subprocess works. So I'm doing the same thing. I'm not doing anything different. Right, so that's why I told you, understanding how the Python functions, how the Python modules work is one of the important points. Okay, here is one more secret. The same kind of libraries like subprocess or modules in like subprocess are available in all the programming languages. Whether it is JavaScript, whether it is Rust, there will be a similar kind of a module or similar kind of a function. You have to just do some research and then you will find it. You will be able to execute the commands right from within the code itself. Understanding these things, understanding how the problem solved in one programming language gets copied to other programming languages. So keep this idea in your mind, right? And then we are trying to execute the communicate process.communicate to get the standard out and standard error, and this is where the interesting thing happens. So we are returning the standard out and we are returning the standard error, meaning this return values go back to the LLMs, right? So when the return data is going to the LLM, then you can process it, you can summarize it, you can make it to check how many elements or how many files are there or which file you want to operate upon. You can do a lot of things. If you have looked at my other videos on agentic IDEs and especially on Windsurf, you would have seen Windsurf is doing a lot of complex activities, but it is actually using a very basic subprocess module which is native to JavaScript, and that is how it is able to spawn those processes and it's able to execute Python code also. Again, it is using native JavaScript libraries for that. So understanding the underlying commands, the underlying packages, the workings are crucial, right? So now I believe that you have understood the steps that the subprocess agent or the command execution tool takes and how the output has been received by the LLM and how you can actually take it to the next stage and then do some processing. So I believe that in this series of videos that you have seen in part 9, you have got a good idea of how the code and the commands get executed on your computer using Crew AI agents and tools. With that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.